Okay, welcome back. Today we're going to be talking about decomposition reactions. So a decomposition reaction is a reaction where we have the breaking down of one compound into two or more compounds. And this essentially what's happening is we have one substance that's breaking apart into its elements. So we're starting with one on the left, one reactant, forming two or more products. So this is the opposite of a synthesis reaction in that we're starting with one compound and then we're breaking it apart. Okay, so that's all you have to know for what is a decomposition reaction. Now we're going to talk about how to balance it. So it's balancing reactions is going to be the exact same through all of these videos. So the first thing we're going to do is start off with the elements. So we have sodium and we have chlorine, and we're just going to count how many on each side that we have. So if you look on the left side, we have sodium, we have one of those. How many chlorine do we have? We also have one. On the right, we have one sodium, and on the right, we have two chlorine. Okay, so now we have to balance it out. And remember, we're using coefficients that go in the spaces in front of the elements, and the coefficients are being multiplied by whatever it's in front of. So we have two chlorine on the right and one on the left. I need to multiply something by 1 to get it to equal to 2. So the obvious answer to that is we're going to multiply 1 by 2 to get it to equal to 2, right? When I multiply by that 2, that goes up in this space. So we have the 2, and I'll put it right in there. That balances out our chlorine. So what happens next is we also put a 2 in front of the sodium when we did that. So that means we need to multiply our sodium by 2. So we didn't just multiply this by 2 because we did that to the chlorine. We did it because when we put the 2 up here, it gets distributed to both the sodium and the chlorine. So that makes our sodium unbalanced. So I have 2 sodium on the left and 1 on the right. What do I have to do to balance it? I just have to multiply it by 2. Right? And that lets us be balanced. So we have 2 salt being broken down into 2 sodium and 1 chlorine. Okay. Moving down. Barium carbonate breaking down. So we're going to do the same thing. We're going to start with barium. And now this is the first type of equation we have where we have multiple elements, more than 2. So in general, I would like to keep the carbonate the same, but we can see it's broken apart. So we're going to have carbon, and then we're going to have oxygen. Okay, so barium, we have 1 on the left, and barium, we have 1 on the right. Carbon, we have 1 on the left, and carbon, we have 1 on the right. Oxygen, we have 3. Oxygen, we have 1. And then we have 2, which equals 3. So, just by looking at this, we know that this is already balanced, right? So there are some of these in your packet that will already be balanced. So you can leave them blank or put ones in. I don't care. So that's already done. We don't have to do anything. Moving to the next one, we have aluminum and we have oxygen. So here we go again. We're just going to count how many of each element we have on each side. So aluminum, we have 2 on the left, 1 on the right. Oxygen is 3 on the left. Oxygen is 2 on the right. So the trick with balancing this is we're looking at the oxygen and we're going to multiply by whatever the other one is. So we have 3 oxygen here, so that's where the 3 is going to go. We have 2 oxygen here, so we're just multiplying it by essentially the opposite of what is on each side. So there's 3 here, there's 2 here, we're going to multiply by the other one. Down here, we have 2 oxygen to start, we have 3 oxygen to start. The least common multiple, again, is 6, so we have to multiply by that to get a 6. So that's a little trick. Aluminum, we multiplied by 2 up here. Again, that 2 is going to both of them, so that leaves us with 4. We then need to multiply by 4 on the right side to get our aluminum to be balanced. We have 4 aluminum and 6 oxygen on each side. Okay, for the last one, we have KClO3 breaking down into KCl and O2. So for this one, we're going to start off with our potassium. We have chlorine, and then we have oxygen. So we'll add these up. We have 1 potassium on the left, 1 on the right. Chlorine, we have 1 on the left, and we have 1 on the right. And then we have 3 oxygen on the left and 2 on the right. Okay, so we always want to start at the bottom. So when we look at oxygen, we have 2 on the right and 3 on the left, and you'll see this is a major trend when balancing these reactions, is that most of them have 3 and 2. Okay, that's because oxygen is diatomic, and most of polyatomic ions have 3 oxygen, so it just ends up being like that. So we need to multiply this by 3 to get 6. We need to multiply this by 2 to get 6, and that balances them out. So we have 3, and then we have 2. Now when we did that, on the left side, this 2 needs to be distributed to each individual element. So we need to bring that 2 out. So we have 2 potassium and 2 chlorine. Now on the right, conveniently, KCl is together. So if we put a 2 here, it automatically multiplies both of those by 2, and that balances out each element. Okay, so what I want you to be able to do from today is to be able to confidently balance a reaction, and this goes along with page number 3 in your packet. And again, like I said in the last video, you have a couple of options when it comes to actually completing the packet. So you could print it off, and you could do it by hand, which is what I would recommend. You could also work with it in Adobe by editing and writing your numbers with your mouse, or you can go ahead and type up a Word document and you'll write out each reaction that happens like this. So you'll write out what you have. So we have 2 magnesium plus O2 yields 2 MgO, and I showed you this in the last video. Now if we were to write the example we have here, I'd say, okay, I have 2 KCl, and then I have O3. So I'd put an O, then I'd come to this subscript button. It's the little X with the 2 below it, and I'd type 3. I'd hit it again to release it, and I'd hit space. Yields, we have 2 KCl, and then we have plus 3 oxygen. O, and then we need to put a 2 on the bottom, so we're hitting this subscript button again. You click it once, put your 2, and then unclick it. And that'll be how we write our reactions out in a Word document. Okay, if you have any questions, please let me know on the Microsoft's team page.